This is how to use the 1980s era Tenshodo SPUD-powered trucks to improve the running of older small brass locomotives. This Baldwin-Westinghouse brass model of an SN, or Sacramento Northern freight motor, started as an Ed Sidem model of a Pacific Electric freight motor. Sidem was an early 1955 importer of Japanese brass traction models, of American interurban electric traction models, of American interurban electric freight motors, and passenger cars. Here's a few views of 661 in action in Moraga and Walnut Creek, California, before being scrapped in 1957. I bought this Sidem model around 1980 and converted it into an SN unit built in 1927. Lots of details were changed, the entire rooftop equipment, and things like the headlights and all the steps for the crew as examples. Earlier, I bought a pair of SN freight motors built by GE and modeled in brass by Model Engineering Works. I was unhappy with the running performance of all these brass models, and in the 1980s I bought a bunch of Tenshodo SPUD self-powered trucks with a 26mm wheelbase spacing to convert all of these models. These trucks were also sold under the Pacific Fast Mail name. It takes 2 SPUDs per locomotive. I wanted to handle at least 8 heavy 40-foot boxcars up a 2% grade. The conversion didn't produce the smooth performance I was looking for, so I just parked all of these models for decades, and just recently I gave these SPUD trucks a second try. They needed all the grease lubricant cleaned out and even a few cracked spur gears replaced due to material shrinkage. This cracking was just from the nylon gears sitting around on the shelf, much like the problem that affected some of the early Proto-2000 HO scale diesels in the present century. The replacement parts were easy to replace, but I couldn't find them for the SPUD trucks. So I bought a few used SPUD trucks just to harvest replacement wheel and axle gear parts. After lots of experimentation, my conclusion is that with careful testing and reassembly, these trucks can run fairly well on DC, but with a DCC controller with back EMF drive and a built-in Keep Alive power reserve, the performance exceeded my goals. The term EMF is short for electromotive force that a spinning motor armature develops when disconnected from the drive voltage. This voltage can be periodically and briefly sampled and used as a tachometer-like feedback voltage to create a servo motor with regulated speed. So here are the steps that I took. The bottom cover plate just unsnaps to reveal the wheel and axle parts with the nylon spur gears that snap into the plastic molded shell. If you pinch the gear and try to rotate the wheel set, the gear should not spin. If it does, you have a cracked gear. You can disassemble the motor and worm gear module from the molded shell. All these parts need to be soaked in 90% alcohol to remove the dried out grease. I tested these for free spinning using the DC lab supply that has adjustable voltage and a way to measure the current draw. This one came from the 1970s. It's an eBay item that I bought for under $50. There's a wealth of equipment like this that is just surplus. In its day, it cost several $100s in the 1970s era. If you want to use a DCC controller, you must isolate the leads that connect to the rails from the leads that connect to the motor. I used an abrasive cutoff wheel to remove the internal links made of phosphor bronze. These small fingers rub on the backside of all the wheels for current collection. These leads will direct the track voltage to the DCC track input from both trucks. The motor leads are now isolated. Next, I ground off the outer axle projections so that they wouldn't touch the brass truck side frames. These brass side frames that came with the locomotive were drilled for supporting the axle projections, and both wheels are insulated with bushings to prevent shorting out, but I didn't want the needless extra rubbing friction. Be careful to keep the wheel parallel to the abrasive disc to not abrade the wheel itself. Let things cool and only grind a bit at a time so you don't soften the bushings or the axle's spur gear. This is how the spur gear is captured on the axle. This is the knurling that keeps the spur gear in place. This damaged gear could slide to the side easily since it's cracked and no longer usable. The SPUD kit's bolsters that space the truck side frames apart were lost decades ago, so I had to fashion a pair out of brass that was 20/1000ths of an inch thick with the center hole to mate with the plastic bottom cover plate. The bolsters have ends turned up to solder to the side frames. I made this sketch and it took several tries to get the truck side frame journal boxes to line up with the axle center line. These bolsters came with some SPUDs that I bought new on eBay that would have made this easier. I used them on 2 other brass traction motors. These parts normally come with each SPUD truck. There are 3 for mounting the truck side frames. Here's the correct bolster I used on the other models that would have worked here if I hadn't lost them. This is one of the 2 shortened truck mounting fingers with a hole matching the diameter of the SPUD truck's mounting boss. This allows the truck to pivot in curved track. The shortened provided truck mounting fingers have been soldered to the chassis. You can see the round mounting bosses protruding through the fingers' holes here. The 2 large rectangular holes in this model's removable brass frame are large enough to allow the trucks to pivot on a fairly sharp radius track. In this case, these holes had to be opened up into a larger size. On some other models, I had to make the brass floor frames from scratch. That was for a pair of Model Engineering Works steeple cab electric freight motors. Here's a look at the bolsters that fit between the SPUD's main body and the snap-in bottom cover plate. The cover plate has a groove that features a centering pin to locate the brass bolster. I made this a press fit by carefully controlling the width. I wanted to avoid using any glue. I made this fixture out of poplar hardwood to act as a soldering aid. This made a press fit between the truck side frames and the brass bolster. The parts have been tinned with solder and ground to a flat condition with added solder paste. A 100-watt soldering iron heated each side until the solder flowed and held the parts in place. This flat block of aluminum helps to prove the squareness of the parts involved. And the side frames are square and parallel to provide the clearance desired to the wheels. The center line of the axles should visually align with the center line of the journal boxes on the side frames. The assembly is wired up to test with just regular DC on a test track. I had to patch the truck pickup leads to the motor leads temporarily. If it runs reasonably smooth with a simple DC supply, it will likely be very smooth under DCC control with back EMF drive. I used separate strips of printed circuit board material to allow connecting the track leads and the motor leads in preparation for wiring in the DCC controller. I bought these surplus breadboard mounting strips years ago for projects, especially for wiring up model factories to lots of individual LEDs. These solid strips are the best solution for cutting to length in locomotives and passenger cars. You can always just buy small sheets of single-sided copper-clad blank circuit board material and cut it up into pieces. This is the brand of small and very flexible 30-gauge insulated wire for model building that I always use. It comes in 10 different colors. This TCS DCC controller hovers above the wiring on a bit of a 1/4-inch diameter styrene dowel stock superglued to the brass floor. So after setting the DCC parameters, this is the initial smooth running performance with the TCS CAM4 DCC controller. I still need to fiddle with the CV2 through CV6 values for best throttle response. And out on the main line with up to 10 cars on a 2% grade, number 661 is as smooth and sure-footed as the real 661 ever was. Look for another video repowering a pair of 1970 vintage brass Model Engineering Works GE steeple cab electric freight motors too.